Something huge happened in AI development back in late 2025. It was a kind of silent revolution that gave birth to a whole new type of role, the harness engineer. So today, we're going to break down what that shift was all about and why it completely changes the game for how we build with AI.
The first hints that something was up came from the top minds in the field. I mean, look at this quote from Andrei Karpathy. When a guy like that says it's very hard to communicate how much things have changed, you listen. He called it a step function improvement. That means AI didn't just get a little better. It took a massive, sudden leap that changed everything for programmers almost overnight. So what was it? What was this giant leap forward? What in the world actually happened at the end of 2025 that suddenly made all these new systems possible?
To really get it, we have to rewind the clock a bit and look at why all the previous attempts kind of fizzled out. For years, the Holy Grail was creating fully autonomous AI agents, but honestly, it was a dream that just kept turning into a broken promise.
I'm sure you remember the hype back in early 2023. Stuff like AutoGPT comes out and everyone's losing their minds. People were literally typing in goals like, go make me $100,000 and expecting it to just work. But by the end of the year, reality hit hard. These systems were breaking constantly. They were failing and failing miserably.
So why didn't they work? Well, to put it simply, the models themselves just weren't ready. They couldn't stay focused. Imagine trying to build a house, but you forget what a nail is every 5 minutes. That was the core problem. They just couldn't handle complex, long-term tasks without getting lost. But then, by late 2025, that core problem, it was solved. We got new large language models that could maintain focus, that could see a long project through. And this breakthrough didn't just revive the old dream of autonomy. It created a whole new way of building with AI, and it demanded a new kind of engineer, the harness engineer. This really marks a huge change in how we relate to AI. We moved from the co-pilot model, where a human is always in the loop telling it what to do next, to an always-on model. We're talking about agents that can manage your entire cloud setup for days, even weeks, while you're on vacation. They can finish huge projects completely on their own.
And this is the absolute core of harness engineering. It's not about writing one perfect prompt. It's about designing the entire system the AI operates in. You're building the environment, the workflows, the feedback loops, everything it needs to handle these massive, long-running jobs.
Let me put it another way. A prompt engineer is like a specialist who sharpens one tool perfectly for one job. A harness engineer? They're more like an architect. They design the entire factory floor, where dozens of AI agents can work together on a complex assembly line for weeks on end.
Okay, so how do they actually do it? Well, what's really interesting is that the industry is already starting to figure out a playbook. Let's break down the 3 core principles that make these new autonomous systems tick.
It all boils down to these 3 ideas. First, you have to create a legible environment, basically a clear map of the project for the AI. Second, you have to build in ways for it to check its own work with verification. And third, and this one might surprise you, you have to learn to just trust the model.
So let's start with number 1, the legible environment. Think of an AI's short-term memory as its context window. Every time it starts a new little task, that window is wiped clean. A legible environment is like leaving a perfect set of blueprints and a to-do list on its desk. It can walk in, get up to speed instantly, and know exactly what to do next. And the big AI labs are already showing us how to do this. Anthropic, for instance, just uses a simple progress.txt file to keep a running log of what's been done. OpenAI uses a central agents.md file that acts like a project's table of contents. The goal is the same. Give the AI a clear, simple source of truth it can always refer back to. All right, principle number 2, verification. This is so critical because, let's be honest, we've all seen this happen. An AI will confidently tell you, all done, when in reality, the thing it built is completely broken. Harness engineering forces the AI to prove its work is actually correct.
So how do you do that? You give the AI the exact same tools a human engineer would use to test their own code. Things like end-to-end testing frameworks, custom linters that enforce the rules, even automated checks that run every single time it tries to save its progress. You're creating a fast, automatic feedback loop so the AI knows instantly when it messes up. And now for the third and maybe the most surprising principle of all, trust the model. The natural instinct for most engineers is to build really complex, specialized, custom tools for the AI to use. But it turns out the breakthrough is to do the exact opposite. There is a fantastic case study from Vercel that just illustrates this perfectly. They spent months building this super sophisticated agent to turn plain English into SQL database queries. It had tons of custom tools, really heavy prompt engineering, and the whole thing was fragile, slow, and a nightmare to maintain. So their solution was shocking. They deleted almost all of it. They threw out all those complicated, custom-built tools and replaced the whole Rube Goldberg machine with a single, generic bash command tool. That was it. The results were absolutely stunning. The system became 3.5 times faster. Its success rate jumped from a pretty good 80% to a perfect 100%. And here's why it worked. They stopped over-engineering and just trusted the model. They gave it a basic tool, Bash, that it had seen billions of times in its training data. The model was already a world-class expert in Bash, way better than it would ever be with their custom tools. So let's just zoom out. What does all of this mean? It means we're playing by a new set of rules now, and this has some massive takeaways for any engineer working today. The most important thing to get here is that this is not just another little update. It is a foundational shift. By using these principles of harness engineering, legible environments, self-verification, and trusting the model with simple tools, we can now build AI systems that are genuinely autonomous and far more robust than we ever thought possible. This is the new baseline. And this leaves us with a really, really big question for the future. If AI can build its own features, test its own code, and fix its own bugs, then what exactly is the new job of the human engineer?